Hi everyone, thank you for taking the time to join us live or in the future for this SuPAR webinar. My name is Maximilian Overholt and I'm a technical account manager at Trillian Quality Systems, and today I'm joined by Ricardo and Ben.
Hi, I'm Ricardo Ponte. I'm an applications engineer here at Trillian.
Hey, I'm Ben Wegrin, head of inside sales here at Trillian.
And we're excited to be sharing SuPAR, an augmented reality inspection tool, with you all today. The agenda is that we'll be going through a brief overview of what SuPAR is and dive into SuPAR's different components. Then we'll go ahead and examine some different industry applications. And finally, we'll have a quick demonstration of the entire process from start to finish. This webinar is presented by Trillian Quality Systems, and Trillian has been a pioneer in the optical metrology solutions since 1998 in the US and Canada. We take pride in not only supplying DIC solutions, but also helping our customers become experts in the technology. We do aim to bring that same energy to the visual inspection space. We partner with CDM Vision, the developers of SuPAR over in Turkey, to bring it to inspectors and manufacturers across the US and Canada.
SuPAR is an augmented reality visual inspection tool that's hugely beneficial for quality part inspections across many different industries. It essentially works by aligning 3D models onto real physical parts using the LiDAR scanner found in certain iPhone and iPad models. The goal is to move away from slower and less efficient methods of quality inspections, things that are not real-time, have slow reporting, and are generally clunky to actually complete inspections. We want to improve the process and save time, labor, and cost with real-time inspections, instantaneous reporting, and mobile 3D to 3D comparisons.
With SuPAR, users are able to cut down their inspection times by up to 80%, all while being more accurate and upholding accountability. Our goal is to move quality upstream by catching defects early on in the manufacturing process and preventing excessive rework.
Now let's take a look at the three products that come in the SuPAR suite. First, we have Composer, where all the prep work for part tracking and inspection templates is completed. Next up is SuPAR, the iPad application that allows us to visualize parts in real time, quickly complete those quality inspections, and generate reports. And then lastly, there is WebViewer, a license-free method where inspections can be viewed by anyone in a more interactive way instead of just a simple document. Up next, we'll be going over these three products in more detail.
Composer is where all the prep work is done on a computer for setting up our models and inspections. In Composer, we can automatically generate tracking geometry from the model's edges, as well as edit the existing geometry to streamline the inspection process. We can also create inspection templates in Composer so that any person can inspect any part by using a guided workflow using SuPAR. There are multiple different customization options for our inspection templates, including descriptions for the inspector, photo and comment requirements, inspection groups to separate different types of inspection checkpoints, as well as artificial intelligence smart points, which we'll touch a little bit more on later.
So SuPAR is our main tool that allows us to carry out detailed and accurate part inspections. Using the LiDAR scanner on the newer models of iPad Pros, it's actually able to find the real edges from the part, and then SuPAR works to match those edges using the tracking geometry generated in the Composer end of things. There's multiple different functions to thoroughly inspect any part. First, we've got the solid model visualization, which actually overlays the CAD model on top of the part. We have the CAD wireframe, which displays the model's edges on the part. And then, of course, the assisted inspection, which really brings out the best, comparing the CAD wireframe to the real edges automatically, allowing you to see those differences. You can open any inspection template in the Composer end of things. With Composer, you're actually able to add checkpoints or specific navigation for your inspectors as well to lead them to different points. We did mention AI as well. We use AI for holes, spot weld, and stud presence detection, working by importing their location data into the Composer using an Excel. The AI model then automatically works to kind of detect whether those holes, welds, or studs are present within that search radius. After the inspection is complete, you'll go ahead and compile all that data into a single report there, including any comments, photos that might have taken, and checkpoint statuses from the inspections, and then it is on for review.
WebViewer is a completely free tool to view past inspections in a more interactive way. Any computer connected to the internet can upload a SuPAR project with a saved inspection and view all the same data while being able to view the model at the same time. This way, further review of an inspection can be viewed by anyone with the project file, and they're not tied to having a license that has Composer. Let's now take a look at some applications for SuPAR in some different industries. In this automotive example, this person will be able to quickly perform an inspection of the spot welds using an inspection template, the navigation arrows guiding him to the welds of interest. The yellow circles denote the appropriate positional tolerance of these welds, and the inspector is easily able to tell whether this weld is within tolerance or not, which in this case it isn't. This inspection checkpoint also requires a comment and a photo, preventing the inspector from moving on to the next checkpoint before providing those. This holds the inspector accountable and ensures an accurate assessment of the weld. He's also able to mark up around the part for clear visibility in the checkpoints associated with this. After inspecting all the welds, the inspector instantly generates a report with all of the data from his inspection into one PDF document. This next automotive application utilizes the power of AI to detect the presence of holes on this part. The AI module works quickly and automatically to check the presence of these holes within the blue search radii, marking each checkpoint as green or red depending on whether the AI is able to detect the holes. The report from this inspection contains all the AI module's findings, including a photo and status of each hole. SuPAR is a powerful tool in automotive applications, from tool and die validation to logistic rack and fixture setups, and all the way up to full body and white inspections.
Now let's examine some heavy industry applications. In this application, we see the utility of the web viewer by looking at the previously completed inspection of these side steps. The user can interact with the model while looking at each inspection checkpoint and its corresponding data. Some are all good, such as these holes and this bracket. This other bracket is questionable as it seems slightly misaligned. Finally, the front supporting bar is bent too far out of shape in a couple of places to be acceptable. This next example shows SuPAR's capability to scale up, which is crucial in many heavy industry applications. We can see here that a large crane formation is being examined using SuPAR's solid model visualization, and everything lines up. As long as we can see a sufficient number of edges corresponding to the tracking geometry, we can scale up significantly. This transportation application follows an inspector performing a more freehand inspection on a public transportation vehicle frame. He's using SuPAR's note function, which allows inspectors to freely place their own checkpoints on the part that are not from the original inspection template, in case there's other issues that need to be specifically addressed. There are several misplaced brackets and holes which indicate a problem with the frame. Similarly large welded bodies are common in transportation applications, so making sure these structures meet quality standards with SuPAR ensures that all the passengers on this vehicle will remain safe on their journey.
At this point, you should be seeing a poll in the Teams chat for some mid-webinar feedback. We'd really appreciate it if you took a moment to answer some questions about the experience so far.
Now I'm going to perform a demonstration of the entire process from setting up a part for inspection, completing the inspection, and then reviewing that inspection using the web viewer. The part that we're going to be looking at is this one, pretty generic automotive parts. And the things that I want to make sure that I have before starting are the part itself, as well as the CAD data for this part, which I've prepared beforehand. The whole thing starts here in SuPAR Composer. This, like we said earlier, was the place where all of the prep work for setting up the inspection is done. I'm going to start an empty project, and we are brought into the SuPAR Composer workspace here. We start in the Model tab because this is where we basically set up at a high level all of the part geometry. We're going to import in the top left and navigate to wherever our CAD data is. I'm going to import this webinar part. There are a number of different file extensions that we support. So we can take care of a lot of different file types. We're going to open that up. There it is. Here's our part. Looks great. Looks like the part, which is good, and it runs well. That's sort of the first step, is making sure that we imported our CAD and it actually looks appropriate. And from here now I can edit this geometry however I wish. If I wanted to cut out certain things or edit the mesh of the parts, this is where I'd want to do it. If I had more of a detailed product tree, I can hide or remove things from that product tree. Say this part's already sort of in a larger assembly and various parts are covered up, I can edit that geometry here. Since I'm just going to be looking at the part by itself, I'm not going to edit any of this geometry, and I'm going to move straight into the AR tracking tab for our edge extraction. Since I want edges from this entire part, I'm going to jump straight into edge extract. And there's a few settings here that we can change depending on the size or complexity of our part. These are the default settings, which for this part will be perfectly sufficient. But these can be edited depending on your part. So I'm just going to click OK and let SuPAR extract some tracking geometry. There we are. These blue lines are those tracking edges that we extracted for SuPAR to track onto. I can change the visibility just to see those edges by themselves if I wish. In the AR tracking tab, I can also manually add or delete my own tracking geometry edges by coming up here to edit lines, which may or may not be necessary depending on what your CAD data looks like. And you might notice that some of these edges look a little strange, or perhaps maybe are even a little bit missing, but fear not, Composer knows what edges should be sufficient for SuPAR to actually be able to use in its tracking. I can always add more edges later if I am finding tracking to be a little bit troubling, but these edges should be more than sufficient for our purposes. The last thing I'm going to do in the AR tracking tab is add a reference view. Reference views are really useful tools if you know sort of the orientation to which you're about to approach the part basically all the time. You can preset that orientation so that when you're in SuPAR, I can just hit a button and that pre-orientation will automatically create itself, and it makes it easier and saves time to snap onto parts. So I'm going to add a reference view here. I'm probably going to come up to this part at an angle something like this. Add reference view, and now it's here on the left. And you can see now there's that camera, there's that sort of perspective line, and that looks great. That's all I'm going to do in AR tracking, so I'm going to move into inspections. This is sort of where the meat and potatoes of Composer lies. This is where we add all of our inspection checkpoints. We add our AI smart points if we want to do that, any markups, things like that. The first step that I'm going to do is I'm going to rename this inspection. I'll call it Webinar Part. Hit OK. I can also open any previous inspection templates or completed inspections that are saved to a SuPAR project. Since this is a brand new project, I don't have any other templates or completed inspections here, but this is where I would normally see them. So now let's add some checkpoints by clicking checkpoints, and I have a little arrow that I can place near wherever my area of interest is. I'm going to start with this sort of support bracket, and our checkpoint menu comes up. This is where a lot of this customization sort of functionality for inspection checkpoints comes in. I can add a description for the inspector, which I will say check support placement. I can require a comment and a photo from the inspector. I can preset any status should I wish to do that. I can edit the checkpoint name. I can also create a group of inspection checkpoints. Say in one inspection template I have a lot of checkpoints for regarding hole placement, and then a lot regarding some brackets. I can create those groups to separate those checkpoints for easier visibility later on. For this part I'm not going to do that, but the functionality is there. So I'll save that checkpoint, add a few more here. I think I want to check this hole placement. Require a comment and a photo. I think there's another hole over here that's been giving me some issues in production. There is maybe this bent piece here we've been having some troubles in our press. I'll make sure that this bend angle is correct. Require a comment and a photo. And I want one more sort of general check, which I want to check the total hole count of this part. For general checks like this that aren't necessarily tied to a specific portion, what we often do is sort of create a checkpoint that's off to the side here and have the description be whatever we want it to be. So check total hole count. For this, I don't necessarily need a photo, but I do want a comment from the inspector saying how many holes that they counted. So save that. And so that's a sufficient number of checkpoints, I think, for this inspection. This will inform me that this part meets our quality standards, and so I think I'm ready to proceed. At this moment, I can also import a checklist of location data for holes, spot welds, or studs to create AI smart points. I'm not going to do that for this part. I can also add in some text markup for, say, a part number that I want to appear directly on the model, or some radius or diameter of a hole, or some thickness, some bend angle, things like that. I can add that text markup right now as well so that it shows up directly on the part when I'm actually performing the inspection with SuPAR. Also something that I'm not going to do for this demonstration. So now I'm pretty much done with setting up this part, so I will come up here in the top left and save the project. Call it webinarpart.spproject. Seems good to me. Let it save. And now the next step is to get this project off of this computer and onto our iPad. So the way to do that, we go to Home, back to the Home menu, and open up Data Transfer. This is the menu that needs to be open for files to be received or sent to and from a device. So have our Data Transfer menu open, connect our iPad, and open up SuPAR. Accept the warning that comes up, and you can see here in the data transfer menu, we are recognizing that an iPad is plugged in, as well as in SuPAR, I am recognizing that I am connected here. So from here, I want to select my transfer mode, which is sending to the device. I can also receive SuPAR projects from the device with completed inspections back onto a computer for further review. But I want to send a project to this device. So I would like to select my file, which is the webinarpart.spproject, open that up, and click Send. There's a green check mark in Composer. There's a green check mark on my iPad. And if I go back to Home and refresh, there's our part. There's our part inspection ready to be completed. So let's now move on to actually completing the inspection of this part. All right, now we're ready to complete an inspection of this part. I've got my part set up here, and I've got my iPad ready to open up SuPAR and complete the inspection. So let's start with that. Let's open up SuPAR. Let the app initialize all of its systems. I will accept this warning, and we can see that inspection, that part that we set up earlier. We can open up this project, and here is our model that we are free to move around. I can also use that reference view from earlier. When the model is green like this, it means that SuPAR is actively trying to match real edges to tracking edges. And since we're not really close to having these aligned, it's not snapping on. So I want to orient this in such a way that we're pretty close to our part. And once I'm pretty close, I can hit here, Start Tracking at the bottom, and we'll snap right on. There we go. We can see the part here in its entirety. And I have a couple of layers on here, so I'm going to turn them off to showcase what they do, and as well as some of these other features before we jump straight into that inspection template. So, for instance here, we can take some snapshots. These are just extraneous pictures that will come at the end of the inspection report. We can use some planar cross sections. This only really works if we have our solid model visualization turned on. So here it is. You can see here that corner is missing because I left this on, but here we can use that planar cross-section tool to cut out certain parts of the model. And when I turn this off, it saves that orientation in space. So, looks great. I'll turn that off for now. The box is a more complicated version of that where we can cut out various different sections like that. Cool. Turn those off for now. I won't be using them in this inspection. We also have a magnifier to zoom in on portions of our part. This is generally useful because if we have, say, a really large part to inspect and we come up really close on the part, SuPAR is going to have a harder time seeing more of the edges and matching them to the tracking geometry. So for larger parts that have a lot more edges, it's better practice to use the magnifier to get up close. For this part, it's relatively small, so I can actually come up pretty close here and not really lose tracking at all. But that's sort of what that tool is for. You have a color palette here. If I want to change the CAD color, I can do that, as well as increase or decrease the CAD opacity. So at 100%, we see our CAD right there overlaid. If we turn it down, we see much less of it. Very nice. In our layers, I talked about the solid model visualization already. I can turn that on and off. We have the virtual lines, which are the lines from the model itself. There they are. We have the actual lines, which is what the what the LiDAR scanner is actually picking up off of the part. As you can see, there's a lot of edges that it's picking up, and it is working constantly to try and match these edges to any of these edges. And that's how the tracking essentially works. The tracked edges layer is basically a combination of the virtual lines and the actual lines. If we turn that on, and we can adjust these thresholds at the bottom, the app is now able to tell us which edges from the real part are matching with the tracked edges that we set up in Composer. So anywhere that's green, the edges match up. Anywhere that's red, they don't. You might see some sort of artifacting here. You can actually see if I cover it up, there's a lot of red. But you can see there's some artifacting here and there. And it's important to keep in mind that SuPAR is still a mobile tool. So if an inspector sees some red edges here, it prompts the inspector to move over and get a different perspective, because since we're using a camera, we need to have the correct perspective to make sure all of our edges are seen correctly. So let's see if I can sort of artificially create some weird edges. See here on the sort of left-hand side, right around there-ish, we have some edges that seem to be okay, but my eye is drawn as the inspector to this red. And so I can come here, get a better perspective. Actually, look at that, it checks out. So that's sort of one way to use the tracked edge function, is to get some eye-popping red visuals to see where things may or may not be defective. But let's go ahead and jump into the inspection. So in the top left, I can open up the inspection. Here's that inspection template that we created earlier. Open that up, and you can see now we have some various point of interest anchors here, 1, 2, 3, 4, and 5. And those are those checkpoints that we created earlier. To start the inspection, we open up the menu again and start navigation. So we're starting with checkpoint 1, and you can see there's a navigation arrow that is helping me and guiding me to where that first checkpoint is, which is right there. And I need to check the support placement. Well, I see a lot of red, and there's nothing really changing when I move around the part. And if I look at my solid model visualization, I can clearly see here, I think I'm missing a bracket. So let's even turn it up here. Yep, definitely missing that bracket. So this is a no-go for us. So X on the status, we can say the bracket is missing. These yellow exclamation marks tell me that these are required items that I need to complete. If I try and hit save, I literally cannot move on from that. So I have to add a picture. We can see here that is definitely missing. You can also associate multiple pictures with each checkpoint. So I'm going to associate one with the solid model visualization turned on, turn down the opacity a bit, and take another photo here. And that's it for this one. So let's save and move on to the next one. I'm getting pointed over to here. I'll turn back on my tracked edges. Getting pointed over to this hole. Yep, that hole is definitely there. So check hole placement. Hole is present. That's a check mark status for me. Get a couple of pictures here. One with those tracked edges that are green, and I'll turn off the tracked edges as well for another photo. Perfect. Moving on, next one is pointing me here. There's another hole to be checked. That one also looks present to me. So that's a check mark. Hole is present. Excellent. Grab a couple of photos here. Oops. And we can move on. That's right, now we have to check our bend angle. And it looks good to me. Yep, not bent too far or too short, so that one's good. Bend angle is correct. Take a photo. Looks great. And let's do one without the solid, do one without the tracked edges as well. There we go. Perfect. Save that. And we have our last one here, which was to check the total hole count. I don't remember, as the inspector, how many holes I'm supposed to have, so I'm going to mark this as questionable. This is for later. I can mark this for later review if I wish. If the person setting up the inspection template knew that hole count, they could put it in here as the description, and then I can immediately mark as check or X. But whoever created the inspection template did not do that. So I'm going to mark this as questionable to be checked later. And really quickly, I will count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. That's 24 holes. I'm not going to include a photo for this one since I probably can't get all of them in 1 or 2 photos, so I'm just going to leave that for now and save that. And now everything from our inspection template is complete. There is one thing I noticed, however, during my inspection. We have a red hole here. That hole is clearly not present. So as the inspector, I feel the need to make that clear. So I can add my own inspection note freehand that isn't part of the inspection template, but will still show up in the inspection report at the end. So that's going to be in the bottom right. I'll hit note and tap close to wherever I need to be, and we have number 6. So that's our 6th checkpoint. Mark that as X. We have a missing hole. Definitely going to add a picture of that one. We'll get one up close. We'll get one up a little further away for the whole context of the part. And I'll get one here without the solid model visualization as well. And there we go. So that's the note functionality, which is useful for extra checkpoints to be created in an inspection. So save that. And there we are. We're done with our inspection. And I'm content with this inspection, so I'm going to save it to the SuPAR project. In the top left, hit Save Inspection. I can change the name here. I will delete this one for now, and I'll call it the inspection, webinar part inspection. Great. I'll add a comment. The inspector was myself. I can also include various types of data in my report. I can choose to exclude all comments, or if I only had AI smart points that I really cared to look at for this inspection, I could remove all the checkpoints. Same with the various status. If I didn't care to see anything that was okay and I only wanted to see things that need further attention, things that are questionable or completely not okay, I can exclude everything that's okay from my report as well. I'll include everything for this demonstration. Come down here, I'm going to click Save to save the inspection to the SuPAR project so that that inspection and the project are tied together. So I'll hit Save. I also think I want to export this as a PDF to send to my boss. So let's save this inspection. All the stuff is saved as before, and I'll export that PDF. And here's that automatic report generation. We can see here are the inspection checkpoints from the template. We have 0 that are unchecked, 3 that are okay, 1 that's questionable, and 1 that is not okay. We also have that extra note that we took from that missing hole here as well. These are hyperlinked as well, so if I really wanted to look at this questionable checkpoint, I can click page 12 and it will take me right there. We have 24 holes, we have the title, we have the description of the checkpoint. We can move up here. This is checkpoint 4 with that bend angle. We have the attached photos. The message, bend angle is correct with an OK status. Those couple of photos. Come down here. Here's that extra note. It's after all of the inspection template checkpoints. We have a not OK. It is a missing hole and a couple of photos. So I'll be able to send this over to my supervisor for further review. So let's save this. I'd like to save this to my files. Come here to my iPad, save it to wherever I'm going to save it. I'm going to save it here to SuPAR reports. And there we go. So that is how to complete the inspection using SuPAR using an inspection template. Let's go ahead and review this inspection using the web viewer now. Now that I've completed the inspection from earlier, I'm going to take a closer look using the SuPAR web viewer at that inspection. I've got my iPad here and I've got Composer open to receive the project from the iPad to the computer. So let's plug it in. Let us open up SuPAR and open up the data transfer window of SuPAR Composer. We'll accept the warning just to move on. We can see that we're recognized, so I'm going to make sure that my transfer mode is set to receive from device instead of send to device. This is what we used earlier. I want to receive from my device. Here's that webinar part project. Let's select that and receive. Choose a place for it. This is as good a place as any. Green check in Composer, green check on SuPAR. And so I can now unplug my iPad and I'm pretty much done with this for the entire process. Now, next step is to open up any web browser and go to web.supar.eu. So I'll open one up, web.supar.eu. And here is the web viewer. This is where we can use this completely license-free tool to take a closer look at inspections while not being tied to any particular machine that has a license for Composer on it. I happen to be on the same machine that has Composer, so I could do all of this in Composer, but if I emailed over the SuPAR project to, say, a supervisor or something, they could go to the web viewer to have a look at the inspection that was completed. So on the left, we can hit this upload icon. This is the empty with just the template. This is the new one with the completed inspection. I'll click that and open it up. And here's that part from earlier. Let's open up the inspection that was completed by coming up here to the top left and clicking Open Inspection. Here's that webinar part inspection that we did earlier. Open her up, and we have the various checkpoints and their color-coded status. So the things that are drawing my eye are these 2 red checkpoints and this yellow checkpoint as the supervisor. So let's have a look. This person needed to check the support placement, and they claimed that the bracket was missing. So let's have a look at the pictures. This is the same pictures that were taken earlier from that inspection. And yeah, that bracket is definitely missing. So that's good to know as the supervisor. Let's have a look at this one. We have a comment here that's a missing hole along with those 3 pictures from earlier. Yep, missing as well. Good to know. And number 5 was here. We have to check the total hole count, and they counted 24 holes. I guess the inspector didn't remember how many holes there were, so let's double check that whether or not there are 24 holes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 16, 17, 18, 19, 20 under here, 21 under here, 22, 23, 24, 25, 26, and 27. There we go. So there are actually 27 holes. And if we think about it, it checks out. We're missing one hole from here, as well as these two holes on this bracket that, since the bracket was missing, we didn't count these two holes. So it checks out that from 27, we're down to 24. That's good to know. So now that I've reviewed this inspection, I can pass along all the information of any defects over to my manufacturing team so that they can rectify whatever needs to be rectified in that process. So that was the entire process of setting up a part, completing an inspection, and reviewing the inspection. As you can see, it's a very simple, straightforward process, but has lots of potential to save a lot of time, a lot of money, and a lot of labor by just doing these quick, simple steps with SuPAR.
Thank you for taking the time today to join us in our showcase of SuPAR. We hope you found the content insightful and interesting. We are thrilled to have been able to showcase how the power of augmented reality visual inspection with SuPAR can help you guys out pushing quality upstream in your production facilities.
At this point, we'd ask you to stick around for a quick and interactive Q&A where we can answer any and all questions that you may have.
Don't hesitate to contact us for any further information. We're always happy to help. Thanks again.
All right. Welcome, everyone. Thank you for your attention. We will now open the floor to any and all questions that you may have. Feel free to type them in the chat or the Q&A function as well, and we'll be happy to answer them.
I have one in the Q&A if you want to take it.
Yeah, sure. We have a question here. Is SuPAR available on non-Apple devices? As of right now, it is not. Right now, the development team started with Apple products because at the time of development, it had better hardware. So as of right now, there is no support for non-Apple devices, but maybe there will be in the future. Who knows? Would the intention be for plant operators to use the technology for quality control? That's certainly a big thing that we see a lot in a lot of our customers is quality control teams making sure that their parts are passing their quality checks before they proceed further in the production process. So that's certainly a big thing. It's also useful in supplier incoming checks or using stages for a larger assembly of sorts. Those are other things that are not strictly quality control, but are very useful to use SuPAR as well.
And to answer John's question as well, can we make automated guidance steps for the inspection for complex inspections? Yes, definitely. That would be a part of the navigation side of SuPAR, being able to walk you through an already set up inspection template that you can then replicate over, multiple different users of the same project as well. So that's way it's nice for accountability. Everyone's working off the same project, same tracking capabilities of that project and everything, but are going to be saving their own reports.
Awesome. Looks like two more came in here.
Yeah. So.
Go ahead.
Yeah, I was going to get the one in the Q&A. Can I use SuPAR without Wi-Fi? Yes, you can for the most part. The only thing that you may occasionally have to connect to the network is to receive updates for either the iPad application or the computer application. That's pretty much the only thing that you need the internet for. But besides initial download and license activation and then the occasional update, SuPAR and Composer are all completely usable without internet. So that's beneficial in large plant settings where maybe either service is bad or various devices can't be on network for security reasons. So yeah, that is, you are capable of using SuPAR without Wi-Fi.
Yep. And then to answer the question of can we have suppliers remotely buy off on parts before shipment, that would actually be a great way to utilize the web viewer tool because then you can just pass along the inspection and the projects file that would have been generated for the SuPAR project. You can pass that along to suppliers or the OEM, whichever way you want to do that. And then they can have a very detailed report, being able to see the model and everything that was taken for that inspection. So you can do it virtually in that sense.
Is it possible to include dimensions in quality control reports? For example, how off the certain measured hole from actual nominal dimension? Yes, sort of. You can include that. There's an extra tool that I didn't show off in the demonstration, but there is a measurement tool. The only limitation with that tool is that you're measuring the CAD data distances. So if, say, you have a portion of a part that is like bent off of the CAD, it's less easy to measure the distance from the CAD to that bent part. But things sort of within the surface, that is a capability of using that measurement tool. So sort of, but yes, to a certain degree, yes, you can include those dimensions in the control report. Alternatively, you can include them in a comment if you sort of measure it manually. That's another option, and include it in the comment, and then the report is holistic in that sense and can be like a one-stop shop for the entire inspection of a particular part.
Awesome. Looks like the next one we have in the Q&A is there a size limit on the size of the part?
Max, you want to take that one?
Yeah. So as far as a limit on the size of the part, no. You guys saw in the webinar there was we were setting up for a line. I believe that was over at one of the Isuzu plants. So we had that entire CAD model of how the line should be set up. We've done everything from a little part like Ricky was showing off in the demonstration, all the way up to even in like the heavy industry side of things, with some of those customers, parts that are 16 meters by 8 meters wide and everything. So size of the part isn't really going to be too big of a factor. The big thing there is how big and complex your CAD model is. The system, as of right now, really shouldn't be going over 7 million triangles or polygons with your CAD model. So as long as we're under that, you shouldn't have any issues, for size of the part. And then there was also one for any spec on accuracy tolerance. Yes, as of right now, with how good the hardware is on the iOS side of things, it's about plus or minus 1 mil. We know that the software is better. It's just being limited pretty much at this point by the hardware for the Apple technology.
We got one. What companies use SuPAR currently?
Plenty. Lots of customers globally. The big users globally are BMW, Nissan. We have customers here in the United States with Ford, as well as Honda. There are many different ones. Max, if you want to throw in any other ones that you can remember off the top of your head. Companies in aerospace globally, companies in heavy industry and agriculture. The sky's the limit. I'm the names are slipping me of companies right now. Max, if you have any off the top of your head.
Yeah, no, you're good. Here in the States, at least, we've got Nissan, Ford, Honda, some suppliers on the automotive side of things. We've started moving into the heavy industry side of things as well, with customers like John Deere, CATS, Siemens Energy, places like that. Obviously, moving into their suppliers as those projects grow. On the transportation side, because we kind of split that off from automotive, you also have, like Volvo truck, Isuzu, like we talked about, and then obviously the aerospace side of things as well, which Ricky already touched on. So Use cases are pretty limitless. It's going to come down to obviously how good that cab model is and how quickly obviously we can get it to.
Yeah, thanks very much, Max.
Awesome.
Can it scan as part in motion? Can it scan in assembly? Sort of. The one thing that you do need to keep in mind if you're even when the part is stationary and you are the one that's moving around the part, we have to maintain visibility of the relevant tracking geometry. So if it's sort of on the line, there's potential for the camera to be obscured, and then SuPAR might lose a little bit of the tracking for a second. So that's sort of the biggest limitation, is making sure that we are continuously seeing the real part edges and are able to match them up with the CAD model edges. That's the biggest limitation with moving parts or parts in assembly. Great questions.
And just as a heads up too, this is obviously being recorded, so we'll get this posted up to all our relevant channels so that you guys can come back into this after the fact and view any of the questions or anything that was taken during the webinar. So if anyone does have to drop off, I know we're a little bit over on time for what we had at least initially set this for. But yeah, we'll get all of that posted up as well so that you guys can revisit it. Can it pick up temperature or provide heat map of sorts? It cannot pick up the temperature, but you are able to overlay XML data for strain as well. So I don't know if that's something that we specifically touched on in the webinar, but if you do have that data available, you can overlay it while doing your inspection with SuPAR. So if you're seeing that there's a split on a part in a specific area, having that data overlaid as well during the inspection, being able to call that out, showing that, hey, we're getting a split here. We're also seeing a lot of high strain here, can really paint the picture and tell that whole story for why you might be seeing something like that.
We have a question: can multiple iPads share a license? No. Each device has its own license. Each iPad has its own SuPAR license. Each computer that has Composer on it will need its own Composer license. That's pretty much the whole answer, I guess. Max, I don't know if there's anything that I'm missing regarding that.
No, yeah, it's SaaS-based software, so it is all going to be tied to the hardware that you use it on. So for SuPAR, obviously on the iPad, on the Composer side, on your laptop or PC. So yeah, you can create different profiles in that license. If you have multiple users doing inspections on one tablet, then all their settings, all their metadata will be passed along with that inspection report. But as of right now, yes, it is one license per device kind of thing. And then we had one from Stephen of how can I get an in-house demo to see it for myself on my own parts. All of our contact information is on the screen right now. We'll also be sending out follow-ups to this too, so that you guys can have all of our information when you're ready to set up an on-site demo. Because trust us, we definitely understand seeing it is, it can kind of get the wheels turning of how relevant this tool might be for you guys. But seeing it on your actual parts is going to be, the biggest thing to help out there. So just let us know however we can help, and we can get that kind of stuff set up.
Yeah, it's really cool to see a bunch of videos, but seeing it on things that you actually work with on a day-to-day basis is really eye-opening, in my opinion. To really see it in action and see how it can benefit your process, it's a really good experience, I think.
Awesome. We got one more. Does SuPAR have any InfoSec docs or any type of document discussing security of our data handling, etc.? Interested in passing along to our IT department to get approvals for use at work.
Yeah, so I was typing up a response to that one, so that it's not so long-winded. But I will check with the CDM Vision team to see what documentation we might have there. But the big thing is that SuPAR is outside of getting updates and setting up that license initially. It is a completely offline tool. So we have ways of being able to transfer those projects or report files to or from the iPad, to your device if you can't have it networked. That's one of the big things with being at Trillian. We come across this kind of stuff all the time, even on the metrology side of things for those systems, not being able to be networked or whatnot. So yeah, there's a bunch of different ways that we can get around that kind of stuff. If you can't have the iPad on network, or we even have customers that they can't have their laptop that they use Composer for on network too. So a bunch of different ways that we can do it, but yeah, there shouldn't be any issues as far as data handling. But I'll see what documentation the team might have.
Another question, this is a good one. Is the AI module learning from my work? No, not by default. The AI is trained on data that CDM processes and implements into their AI model. By default, the AI model, when you use it, does not learn or get better from the inspections that you carry out. But that is a conversation that we're willing to have. And if you end up wanting to submit some of your inspection data to as training material for the AI, then we can have that conversation and get that involved and make the AI better for your process as well.
And we had one in the chat too. Does SuPAR work with a 2D AutoCAD drawing, top right front views? As of right now, we do need to have those specific CAD file types. So JT, STEP, STL, VRML, native CAD files as well from like CATIA for like a CAD part, CAD product, anything like that. Those are going to be the limitations of it. So we definitely need those kind of files. And we can always...
I just wanted to jump in, and
Yep.
I forget I haven't tinkered with like an AutoCAD. I haven't tinkered with AutoCAD in a little while, but I believe there is functionality if you have like the top, front, right, left, bottom, all of those. I believe those can be sort of incorporated into or sort of assembled into a 3D model. I believe, like I said, I haven't tinkered with AutoCAD that much, but that's one way we can interface with those 2D AutoCAD, since AutoCAD is very popular in like drafting and 2D drawing and stuff like that. I believe there is that functionality within AutoCAD to generate those 3D models from that, and then we can use that with SuPAR, no problem.
Add one. Is there an option to transfer data from iPad to computer or vice versa over the air, or is plugin required? As of right now, plug-in to some sort of device is required. You can't do it over network per se as of right now. But if you, going back to like the security questions and whatnot, if we can't plug in the iPad to your device that has the Composer software on it, one way that we've gotten around that is just offloading the project file onto a USB stick and figuring out how to plug in that USB stick to the iPad to get the project onto the iPad that way. But yeah, as of right now, over the air is not something that we're able to do.
Great.
Looks like we got one more here, and then we'll be nearing the 3 o'clock hour. I don't know what iPad model I don't know what iPad model I have. How can I tell if it's compatible?
Yep. So easiest way for that is to either go to your settings on your iOS device and clicking on, I believe it's General and then About, and that will tell you what iPad or iPhone model you have. The other easiest way is looking at the iPhones. The camera that needs to be on there is the little LiDAR camera on the back of it. So I believe for iPads, it's the Pro version is what they call it. For iPhones, I believe it is the iPhone Max or, whatever version they call it there. As of right now, I believe it is best used definitely with iPhone 13 or newer. And then iPads Gen 4 newer is going to give you the best capabilities there.
Awesome. Do we have any more questions here? Anything left unanswered for you folks?
No one else has any questions as of right now. Like we said, that's completely fine. We'll send out all of our contact information, link to this webinar and everything once it's uploaded to our proper channels there, so that anyone can revisit it, as well as if you guys have any follow-up questions that might not have been answered during this time, you can always follow up with us individually as well.
Yep.
Nathan is a license purchase good for life. It is a yearly license, so you get all of the updates and everything that comes along with it for that first year purchase, and then it's just a renewal after that.
Awesome. Thank you, Max.
Yep. But yeah, no, thank you so much, everyone, for joining us today. Like I said, if you guys have any questions, feel free to reach out. We are all based out of our Novi, Michigan office here at Trillian. So like 40-ish minutes right outside of Detroit. But we go all over. We cover all 50 states. So if there's anyone that is not local to us that needs a demo or anything, we have team members all across the U.S. that can help you out.
All right. Well, we really appreciate it again. Attendance was really fun. First webinar here for Trillian, SuPAR Technologies. So we look forward to you guys reaching out and really just setting up some demos and getting these guys in your hands.
Absolutely. Thanks everyone for joining. Appreciate it.
Yeah. Thanks, everyone.